Oscar. Hi, Darren. Did everyone have a good weekend? Pretty good, other than hot. Right? Hot, hot, hot. I have a desert tortoise that's even hot from my desert tortoise. She's not a happy camper because their hole isn't cooling off. You know, it's so hot it doesn't cool down at night. Okay, so let's talk a little bit more about administrative distance. If you remember last week we talked about administrative distance, and I said it's something that's not in the book, right? But it's something that you want to know. It shows up on the CCNA, and it's just something you need to know for routing in general. So there's two types of routing that the book talks about. What are the two types of routing? Dynamic and static? Yeah, dynamic routing and static routing. And what's the purpose of a router? Like, what's its main job? It does a bunch of stuff, but what's kind of the main thing? It lets us get to the outside world, for sure, yes.
Finds the best path.
Finds the best path, right? Finds the best path. So that's really what I want you to keep in mind. The router is looking for and keeping track of the best path or the best route. For whatever reason, Cisco likes the word path, and so that's usually the way you'll see it when Cisco is talking about it, but sometimes you might also see it as the best route. I think the reason that they refer to it as path is because when, like the routes between ISPs are called paths, a path vector. So I think that's where the word path comes from. And what is administrative distance a measure of? Trustworthiness, right? Trustworthiness. Now, trustworthiness is a fancy way of saying the best path. Okay? It's a fancy way of saying the best path. Is a lower number considered better or a higher number? Lower number, right? Lower number. So typically, a static route is going to be an administrative distance of 1. Okay, a static route will be an administrative distance of 1. Now, if I say something's directly connected, what am I talking about? What am I saying as far as a route goes? Okay, to which device? To the router, right? So if you think of yourself as the router, and you've got an interface gig 01 and a gig 00, this is directly connected to me, right? I mean, I know what my own interfaces are, kind of like I know what my own arm is, okay? So a directly connected route has an administrative distance of what do you think it would be? If a static route is 1, what might the administrative distance of a directly connected route be? 0. Because if something is a static route, that means that I manually typed it in. Like I gave that direction to the router. So in the absence of human error, that means that I am controlling that route. So the thought is that that would be a 1 because I'm dictating where I want it to go and how I want it to get there. That's why it has a 1. A directly connected route, again, it's attached to me, so that's what makes it a 0, okay? And then dynamic routes, what's the advantage of a dynamic routing protocol? There's a couple. Say that again? It is automatic, and so what about it's automatic? Not exactly the addressing table, but you're on the right track. So
It'll find the best administrative distance, so even if there's something breaks on a network or a cable's broken or something like that, it will find it.
exactly. So it will automatically find the best routes. It will dynamically learn the routes. Now, as far as administrative distance goes, each dynamic routing protocol has their own administrative distance assigned to it, and that is static. It doesn't change. So for example, there's a routing protocol called OSPF. That administrative distance is 110. Okay, so write that down. OSPF has an administrative distance of 110. Now, OSPF is the most common dynamic routing protocol in use today. Okay. Now, Cisco has a dynamic routing protocol called EIGRP. EIGRP. And the administrative distance of EIGRP is 90. Now you would think, oh, so EIGRP is better or faster or more trustworthy. It actually isn't. They've done head-to-head testing of OSPF and EIGRP, and from a scalability or a convergence, it's really, they're almost exactly equal. But EIGRP is Cisco proprietary, and it wants to be better than everyone else. So they assigned themselves the administrative distance of 90 so that they could beat everyone else. But it's really, it's very comparable to OSPF. The difference is OSPF is open source. Now, EIGRP has actually opened themselves up, so Cisco has made theirs so that you could run it on different devices. But more often than not, you're going to see EIGRP running in a Cisco network, mostly. Okay? And then there's another routing protocol, which is a little bit more legacy. It's called RIP, R-I-P. And that administrative distance is 120. It's slower. It is actually, if you were to do a head-to-head test, it is going to be slower than OSPF or EIGRP. But it's pretty common. It's still in use fairly often. What we find is sometimes companies will use RIP on their edge network, or they'll use it as a backup. So they might be running OSPF, they might be running EIGRP, and they'll run RIP as a backup. That way, if there's some failure, RIP's there to pick up the slack. Okay? And then there's one more that I want you to jot down, and it's called ISIS. ISIS. Yes, ISIS. And that's 115. 115. Okay. Got it? Okay. So again, it's a measurement of trustworthiness. It's a complicated algorithm that figures out all of those numbers. So what routes go into the IP route table? It will be the routes that it discovers, but it might discover like a gazillion routes, the best ones, right? So remember, the best routes go into the route table, right? So if you did a show IP route, you're going to see the best routes. You're going to see the best routes, okay? And there's a couple of other tables that routers keep track of all kinds of things, right? They keep track of ARP tables. They keep track of DHCP tables, NAT tables. They keep track of a gazillion things. But as it relates to routing, they're going to keep track of IP route tables, neighbor tables, and topology tables. Okay? All right. So if I were to see a C in the route table, what does the C represent?
Directly connected.
A directly connected what? Network. The C is a directly connected network. And what letter would represent the directly connected link address? L, right? An L. An L. Okay. So for some reason, and I'm going to have to take the blame for this, only one person, Tim, completed the homework assignment that I gave on Wednesday. So I'm going to take the blame since nobody else finished it. Paul, you got started on it, but you missed a few things. So I am going to take the blame because nobody did it. So I'm going to assume that means I did a terrible job assigning it. And we're going to do it today. Okay? Descriptions and routing. Okay? So we're going to do this assignment today. Huh? Yeah, that's why I said I'm going to take blame for it. So if you would go to modules, I think we had a lot going on. We were doing a lot on Wednesday. So what are we? We're in week 7, right? We're in week 7. So it is this worksheet, packet tracer descriptions and routing. It was due last night. You've got to be in the VM. So I want you to download the Word document and the packet tracer. Now, I have been told, but I haven't tested it, I've been told that the Word document problem has been resolved in our virtual machines. So let's give it a go and see whether or not it actually has been resolved. Ooh. Enable editing. Look at that. It looks like it has been resolved. That's lucky. And they told me that it was impossible. I'm like, how hard could it be to add Word? Come on now. So I feel very happy about this. All right. So last week we talked about, we practiced VLSM. We started talking about routing and the route table. Okay, and descriptions, It was due last night. Well, look, you got it done, so that's a good thing. Okay, so depending upon what you've done already, you're going to see something that looks like this, okay? So when you have your packet tracer up, can you raise your hand so that I know that you have it open? Okay. Is everyone's Word working? Oh my gosh. Hallelujah. I reported it the first time in February. Now, in February, it was only happening on 1 or 2 devices. And so they said, well, can you do a workaround and like use Google Docs or something? And I said, oh, sure. And they're like, okay, we'll start fixing it. Well, then, licenses kept expiring, and then we had 3 and then 20 devices, So I think, and normally the workaround would be cool, except it's hard to grade when you submit things on WordPad. It does, the formatting's different. Google Docs you can't get if you're offline. Okay, so are we here? Does everybody have this up? Are we close to this? Okay. So the first thing we can see is that our router is not connected, right? Okay, so first of all, let's just, again, we're going to kind of pick up where we left off. I want you to go in there, and I want you to do a show IP route. Okay, so do a show IP route. Now, if you've already worked on this a little bit, you might see something in there, but I don't have anything because I don't have anything connected, right? So there's nothing for the router to have learned. I haven't connected anything. So if you've already made your connections, you might have something in there. But if not, let's make the connections, okay? So I think we made the first connection before we left. So you want to go get a straight through. And you're going to connect G00 on your router up to G01 on switch 0. Okay? So you're connecting G000, I think, to switch 0's gig 01. Okay? If you connected it to a different port, just move it so that we're all doing the same thing. All right? Because like I know, Paul, you had done yours and you connected it to like F05 or something. Just move it to G01 so that we're all doing the same thing. Okay? And then let's go ahead and connect up G001, and let's connect that to switch 1's gig 01. Okay, so we're connecting our router up. And what kind of connections are these? They're straight through. But what's the connection? How is it connected? Directly connected. It's directly connected. Okay. So when you have both of those connected, just pop your, and they've turned green, just pop your hand up so that I can see. Thank you. Okay, so we might have to set up addressing. So let's see, go in and see if there's any addressing set up, or if your ports are on. How can you check that? What would be a better way than show interface? What would be a little bit more concise way to do it? Show IP interface brief. Show IP interface brief. Now, again, I have already done some of mine, so I'm going to see something probably different than what you're seeing. If yours haven't turned green, it's probably because your interfaces aren't set and ready to go. So we're going to want to do that. So let's set up these addresses, okay? So if you scroll down on your Word document, it wants us to do addresses. Does a router work if it doesn't have an IP address? No. What layer does a router work at? And what happens at layer 3? IP addressing. So that's why a router has to have an IP address. So if we look here, here's our router. Now G000 says to use the first usable address, right? So if you look here at our topology, it gives us our network address of 10.10.00.24. So what's the first usable address, Alan? So if our... not that, you're on the right track. So the last host bit. Yes, yes. Okay, so 10, let's get that in there. Why is this not working? Huh. I'm not being able to type in mine. Is everyone being able to type in yours? You can't make changes because it says that my selection is locked. Is anybody else having trouble typing in there? Marcus, will you see if you can figure it out? Oh, I think mine is still messed up. Mine is still messed up, I think. Product activation failed. Okay, so mine isn't working. Okay, so why does it say NA where the default gateway is? Not exactly. It is the default gateway. Everyone hear that? So when we add this IP address of 10.10.0.1/24, this is the default gateway address. That's why it says that it's not applicable, because it is the default gateway. That's really important to understand, okay? So what about the first usable address for G001? What is it, Blake? Okay. Okay. 192.168.0.1. Okay.
Yeah, I think all of these computers are working.
Okay. So the network address for this network, right? So the first usable address would be 10.10.0.1. The network address for this whole network is 192.168.0.0. So this IP address is going to be 192.168.0.1. So now you're going to assign the IP addresses. Okay, because if we don't put an IP address right here, can these devices get in or out? Can the messages or data get in or out if this does not have an IP address? No, okay? So you have to go into this interface, G000, and assign that IP address. Okay, so open up WordPad. And then, Marcus, we need to jot down any ones that's not working.
Yeah, we'll put down yours and this person.
Yeah.
Go ahead and use WordPad. You can open it up. Oh, if you can do it in there, then that'd be perfect as well. One thing you could do is open up a Google Docs on one side, copy and paste it into the Google Docs. Open up
Okay, so has everyone got this going? Are we working on this, getting the interface set up? And then what command do you have to add to actually activate it? No shutdown, right? No shutdown. Got them both, Jonah?
Yep.
Perfect. And then, yeah, see, nice. Now you can see that they're directly connected, right? Go ahead and get those in there. Okay. Well, let's see, did you add the IP address?
I have this, I have the 10.10.10
Well, this is the 10.10.10 one,
Okay.
and you got to add this
To
one.
the switch?
Nope.
Oh, to here.
Mm-hmm. Because this is G000,
interface,
that's
okay.
G001. Remember, every LAN needs its own interface on the router so the traffic can move in and out. Okay? So you got that one, right? And now you're working on this one?
But yeah, what I put 1 for that.
Mm-hmm.
Yeah, okay.
Yeah. This one is G00, and that one's G001.
Okay.
Yep, they're both directly connected, right? And there might even be another one, I don't know. But we're not using it. Okay, so once you get those, you want to also work on the rest of the addressing. So VLAN 1 on switch 0, right? Again, you're working with this network address. So what would the last usable address be? And the default gateway. Okay. Switch 1, it's a different network, right? Marcus, if you have time today and this week, maybe start checking these other devices too.
And just run through them and
yeah,
see if they actually.
so that we can report whichever ones don't have it. And I've got the direct contact of who's helping us with it, so we can send it to IT, but I'll send it directly to him too. We'll copy him on it too. Did you get it? Okay.
Asking that question, what you're asking for now.
Yeah, see, it's telling us what the network is, right?
Yeah.
And then where's your Word document? Okay, so now we want to look at switch 0 and get what's the last usable address, and that's what we're going to assign to VLAN 1. So for this network, what would the last usable address be?
255, 254?
No. So a 24, so that means this stays the same, this stays the same, and this stays the same. Yes, yes. Okay, so fill in the address. So let's see, so Blake, what is it for VLAN 1 on switch 0? Exactly. And then the default gateway is the 10.10.0.1. Right? Jonah, what's the switch 1's VLAN address?
192.168.0.254.
Exactly. So you're going to add the interface address onto the switch. So how do I do that? How do I add an address onto a switch? Okay. Oops. There. Then what? Okay, interface. VLAN 1. Okay. Okay. 10.0.254. Yep, subnet mask. Then what? No shutdown. Right. Okay. So once everybody gets their VLAN addresses, can you just stop for a minute so we can talk about that? So once you've got your VLANs on there, then just hold tight so that we can talk about that. Actually, I'm just going to stop for a second. So you're going to be putting your interface VLAN 1 10.10.0.254, and over here on this one, interface VLAN 1 IP address 192.168.0.254, and do a no shut, and then just hold tight there, okay? And then pop your hand up so I know that you've got the interface VLAN 1s on. Okay, great. Oscar, do you have your interface VLAN ones on? Tony, do you have yours on? You're doing it? Marcus, can you see if Tony needs any help? Okay, so let me ask you a question, all right? So can I get everyone's attention? Do your switches need IP addresses for your network to work? No. Okay, this is really important because a lot of you missed a question on one of the labs about that. Like the question says, why doesn't this work? And a couple of you wrote, because the IP addresses haven't been added to the switch. The switch could care less if it has an IP address. It does not need an IP address for anything at all to work. Okay? Why would I add an IP address to a switch?
For like a VLAN.
Exactly. The only reason for what we know at this time, we're going to learn more in 150 about VLANs, okay? But for us, the only reason we add an IP address on here is so that I can get into this device remotely to give it directions or to pull information off of it. So if I wanted to go on vacation to Hawaii, I could be gone and I could still pull information from the switch, or I can give it information. I could also say, Aiden, I'm going to Hawaii. I've set up VLAN 1. I want you to manage the switch while I'm gone. Okay? So that's the whole reason for adding VLAN information to the switch. Now again, in 150, we're going to learn a million more things about VLANs because it is the foundation of all networking, all right? But for what we need to know, a switch doesn't have to have an IP address on it. The absolute only reason we put one on there at this point of our understanding is so that I can get into it to give it information or pull information from it, okay? So I didn't add a VLAN address to this at this time, but everything will still work. I can come over here, and I think I have everything set up, and I would be able to talk to this device. I think I have, can't remember if I have everything set up yet, but I think I do. Yep, I do. So see, there's no IP address at all on this switch, but my network is still talking. Okay, so that brings me to the ping. All right, so why do I use a ping? What is the whole point of a ping?
Verifies that there's a connection on end-to-end.
Right, and what layer is it functioning at? Layer 3. Okay, so a ping, that's called an ICMP. Okay, so an ICMP, that's the protocol, and what ICMP does is pings. Okay, so ICMP is the ping, and that is the protocol that just allows us to verify layer 3 has functionality. Okay, it allows us to verify that it has functionality. Okay, so now what am I going to find if I look at my show IP route statement now? I will see if I do a show IP route.
Oh no, so if you just ping that one, you'll see those devices.
So if I do a show IP route, so do a show IP route on your router. Remember, a switch doesn't keep track of routing tables, so we're doing it on the router. And now what do we see? Remember, when we looked the first time, it was empty, right? Right, Andrea.
Right.
Okay. So we can look here, we can see C, we can see the directly connected network, right? 10.10.00.24. we can see the directly connected link address. Remember, I said that we could call a router's interface a link. Sometimes they call it a link. Okay, it's the same as an interface. You got to learn these different terminologies. Okay, now here's a tricky question. Let's see, based on what we talked about with administrative distance, okay? Notice here that the network, it's a /24, which we know it was a /24, right? 10.10.0.1, that's the address of our default gateway, the interface address. Notice how that says it's a 32. So how many bits are in an IPv4 address? 32. Why does it say 32?
Because it only needs the 1 bit for the default gateway.
Not exactly. So again, this is a little bit higher level concept that we're going to talk about more in 150. The reason is because it's going to use all 32 bits to make it a 0 administrative distance. So it's like, oh, all of these bits are important. That's how I know that that's directly connected. It's just what the router uses to help itself. It knows that it's going to have all 32 bits associated with that interface when it's making a routing decision, okay? And then here we've got our next one, 192.168.00.24. Here's our 192.168.0.1. Okay. So based on module 11, so module 11 was about IPv4 addressing. What is this? Why is this 10.0.0.10.0.0/8? It is part of the private address range, but what else is it? What class is it? So that was module 11. We talked about private addresses and public addresses and class A, B, and C. Why is this a 10.0.0.0/8? So module 11 notes, get your module 11 notes out. What is a /8? What class of address is that? Class A. Class A. Okay, so and we're going to talk about that a little bit more today. So a 10 is going to be a /8. Okay, so here's what I want you to notice about this. This is really important. Did we ever type in anything that said /8? Nothing. All we did was a 255.255.255.0. Why did the router give it a /8? Muscle brain it. Because it doesn't I mean, it tells you in the book, but it's not super, super clear.
It was because we gave it a /24 and the 8 is remaining?
No, that's not why, but that's a good, I get where you're coming from math-wise there, right? 32 minus 24 is 8. You're on the right track. You're on the right track. Okay, here's the reason, and we're going to see this again, and this is so important when you become a network administrator. These devices have a legacy brain. They have a legacy brain. So when you put a 10 address in there, it thinks that it's classful addressing. So a 10 is a class A. So it automatically gives it a class A /8. Same goes with this one, 192.168.0.0. What class is that? A C, which is a /24. Now it just so happened that we gave it a /24, but it's legacy. It's legacy. Okay, so here's something I want to show you. So go in and pull up your control panel. And go in like you're going to change your address. So go in like we're going to change our address. for IPv4. Okay, so we can see here that we're getting our address right now through what? DHCP. Okay. So is everybody here? All right. So let us do this. So we're going to type in this address. Let's type in, use the following IP address. Type in 10 and see what happens. What does it do? It automatically puts it as a /8. Did you see that? It fills out the subnet mask, 255.0.0.0. It's classful addressing. All of these devices, their brain is set to classful addressing. Very rarely do we ever use classful addressing anymore. What type of addressing do we mostly use? Classless, classless. Okay, so let's go obtain an IP address automatically, just to clear it. And then let's go back to use the following IP address. So now let's do a 172.40. And what does it do? Now notice how it waited till I went to the second octet, right? So what class is this?
16.
It's a 16. It's a class B. It's a class B, and it automatically fills it out. So we, as network administrators, have to be really cognizant of the fact that our devices, our routers, and our hosts have an old brain, have a legacy brain. So you can't just assume that it's going to put the right subnet mask in there. So we've got one more to do. What will a class C, what do I put in for that? 192. What else? 192 by itself doesn't work. 168. Oh, and it still wants more. There we go. The legacy brain fills in the /24, the 255, 255, 255. Okay? All right, so let's go back to DHCP, obtain the address automatically, and cancel out of here. So again, super important to remember the legacy brain. Okay, so this assignment wants you to copy and paste the route statement. And you're putting that down here. And then it says to highlight the directly connected networks. So which one are you highlighting? The C or the L? The C. Okay, so get that in there. Now I think the address is already filled out on PCA. Like I think if I come over here and I did an IP config, it's already in there. Or not, I don't know. Let's see, is it? Yeah, it is. But it's just wanting you to test yourself. What would the second usable address be from the blue network? What would the second usable address be from the yellow? But you don't have to set it because it's actually already set for you. Okay, so you're filling in the addressing. Fill it in? Okay, that's fine. You don't have to change them, but if you did, that's fine. Okay, what's left to do? Descriptions. Okay. So we're going to go ahead and fill out this table for our descriptions, okay? And then you're going to enter them into your device. So let's start out with our router. So what is the source device right here? R1, or main, it's actually R main. What interface? Yep. G000. And what does it connect to? S0. What interface? G01. And let's just call it LAN, I don't know, let's call it LAN human resources, just because we can. Okay. What's the network address? And we don't have an IPv6 network, right? Okay. All right. Oscar, you do this one for me. So what about the other interface on the router? Okay, G001. S1. Nope, this one connects to G01. So look at your packet tracer and see which one you've connected it to. Do switches have G00s? No. This one's connected to G01. Oh, is it connected to G01? Oh, sorry. You got to keep me on my toes. I think I connected mine to G02, so I have mine in my brain that I connected to G02. Sorry. So you're on G01. Okay, so then let's just call this LAN, give me a name. Sales. Okay, all right, and then network. Okay. All right, so go in to your router and add your descriptions. Okay, so you've got to go into your router onto G00 and just add this description. Then go into G01 and add this description. Okay, so go in there and do that right now. When you have those done, pop your hand up so I know we can move on. Thank you, Oscar. Is my water back there, Marcus?
Last thing I saw is next to the instructor center.
I don't see it. Where did I set it down? It's weird. Hi, John. Okay, everyone done with the gigs on the router? So now where do I need to think about next? Switches, right? So now we've got to go from here back. Okay? So Tim, do this one for me. S0, G01, 2, R main, G000, and it's still the HR LAN, right? And the network? Okay. And then let's do the VLAN as well. Okay, can you do the VLAN for me, Tim? Okay. S0, VLAN 1. Does it connect to anything? It doesn't connect to anything. Okay, so a couple of you made that mistake. It doesn't connect to anything. It's just there for management. Okay, so here, what's the function? Yeah, so I can either put management or I could put remote access. Okay, and what's the network? There we go. Okay. Yes. Every active interface needs a description.
Well, no, I mean the network portion of it.
Yes.
I haven't put that down.
Yes. Always follow that format. You always want to have the network. Okay. Now, for this assignment, you don't have to worry about these right now. Okay. I want you to get these and the SVI. Normally, you want to get these too. Just to save time, I don't want us to do them. But every active interface needs that format. Okay. When you've done that, then go and do the other switch. Okay, go and do the other switch. So then you're going to get your other switch done. Now, is it a good idea to also put a description on your inactive interfaces? Is it a good idea to put a description on your inactive interfaces? Yes. Just say, you know, shut down for security. Don't activate without permission or something like that. Again, you don't have to do that for this assignment. I just want you to kind of put that in your brain. Marcus, can you walk around and make sure everyone's got it? Oh, perfect. Yes.
I'm trying to answer the command for that, but I'm not sure. I can't-
Interface. So are you on the switch or the router?
I'm on the switch.
Okay, so type it, so go back and type DO space show IP interface brief. And then just hit enter. So hit the space bar again. So see, here's your interfaces, G01 and G02. You don't actually have a 001.
This is
And-
0-1.
Right. So what you've done is, first of all, you're using the wrong one, right? Because you don't have that. And then scroll up a little bit. Right here, you actually did it twice because you did interface gigabit and followed by the G01. It's one or the other, not both. Okay.
Okay. So I gotta delete this.
Well, you don't have to delete it. It didn't do anything.
Oh.
It doesn't work. So just hit the enter key a couple times. Okay. So hit the up arrow. Hit the up arrow again. So just come in here and
Get rid of all
yep.
that.
And then you got to get rid of either the G here or the gigabit because it sees two of them. You can't.
Oh, I thought it was two different.
No.
Okay.
Mm-mm, it's
alright.
the same thing. This is just the abbreviated version.
Okay, that's what I was making confused.
No. Yeah.
Do it all over and over and over for each interface. Copy and paste that whole thing from Notepad into the console. You still have to type it, but
What was your question, Aiden? Was it about the range? Hi, Nickman.
I'm broken, I have at home, could you int ETH or 111 to 1148 and ETH to a public action?
You can do that here.
Yeah, that's the same thing.
yeah, you put in interface range and then, for example, X01.
It's here. There.
Yeah.
So I just did it up here. Interface range F0, 10 through 24. And you can do multiples. So like I could do interface range F24, comma, G02. So I could do interface range F010, 24, comma, G02. And then I could do like a shutdown, right? And then I could do description, shutdown for security. And then there it is. Okay. All right, Blake, you got it now? Is that one working? Alan, how's it coming? Paul? Got him? Excellent. Okay, so make sure you've got your descriptions on your switches and your routers. So it's got to be on the device in the packet tracer. That's where I'm checking the descriptions. I'm actually looking at your packet tracer. On your VLAN?
On all of them.
Oh, how's it coming?
The switches and routers, how do you put the default device?
Oh, okay. So go in there, go into one of your devices, one of your switches. Okay, and then type in IP space default hyphen gateway. And then, nope, up arrow. Now put in the gateway address. Good question. I'm going to talk about that. So Jonah had a great question. When we add, well, I'm going to wait till everybody's done because I don't want anybody to miss it and I can see everyone's duly engaged with their. I'm waiting. Did you add your default gateway to your switches? Okay, I'm going to talk about that next. IP default gateway. Okay, I'm going to do it together. Huh? I wasn't checking for that, but I want to talk about it because it's a good. Uh-huh. Mm-hmm. And it happens all the time. Uh-huh. When you're done, raise your hand. Okay, okay. So what we want to have done is the interfaces and the descriptions on your router and your switches for your gigs and your SVIs. Thank you. Thank you. And then don't upload it yet. We're almost done, but I want to just talk a little bit about the default gateway on the switches. Uh-huh. Mm-hmm. Okay, so when we set up a static IP address on a computer, on a host device, when we set up a static IP address, we've got to give it three things. What's the first thing?
The IP address.
The IP address, and then we also have to tell it what?
Subnet.
And we have to tell it its default gateway, okay? When we add an IP address onto a switch, the switch also usually needs to know what its default gateway is. However, we don't have like a GUI, we don't have a control panel for the switch, right? We really only have the CLI for the switch. So that's why it's important. Now, with this small little network, and we're not really doing anything with it, not putting an IP default gateway on there isn't going to stop anything from working. But going forward in the future, as we start to expand our networks and do more things, having the default gateway on the switch is going to become important. So it's just a good idea to get in the habit of adding the default gateway to the switch too. That way, if it's getting traffic, layer 3 traffic, which is moving through it, it'll be like, oh, that's meant for me. That's coming to the right place, okay? So again, just keep in mind, I don't have a GUI. I don't have a control panel for the switch. So that's why I have to manually add it. And the command is just IP default gateway, and then I got to tell it, by the way, your default gateway is 10.10.0.1, okay? It doesn't need to know the subnet mask because frankly, it's just not that smart. And if it's getting traffic from the default gateway, that's enough for it to know, okay? That's enough for it to know. So let's also go into each switch, and let's go ahead and give it its default gateway. Okay. Now the other thing I want you to get in the habit of doing, because it will save you a tremendous amount of time, is when you've done something, just go check it and make sure you actually see it. So let's just go do a show run and just look for that default gateway and make sure, A, that it's in there and that you typed it right. Okay? Every time you do something, take the next 30 seconds and just check it. Just check it. It will save you so much trouble in the long run, especially as we start doing more and more complicated protocols and labs. Because if you go in, so let me give you an example of something that happened in my 150 class. We're doing something called STP, Ether channel, and DHCP, okay? So a protocol called STP gets set up. After that, we set up something called Ether channel, and then we set up DHCP. Well, the student, something wasn't, so they're all done with their lab. They check it, and something doesn't work. Well, was it the STP? Was it the Ether channel, or is it the DHCP? If you had just checked it after STP, oh, everything's working. I'm golden. Now I add Ether channel. Oh, something's not working. I have to fix Ether channel before I go on to DHCP. But because the student had added everything and then tested it, that makes the troubleshooting so much more difficult, right? Ultimately, he had to back out the DHCP and then test Ether channel. The trouble was with, what's the trouble? I don't remember now. I think the trouble was with Ether channel. But if you just check as you go, right? So I want you to get in the habit, and that's a good life philosophy, right?
Especially with computers.
Exactly, or the shopping list. Let me check the shopping list before I leave and get home. Oh shoot, I didn't look at the shopping list and I forgot milk. If I would have just, yeah, exactly. It's the same, like this is just a good life philosophy, right? Check as you go, right? And it really works in IT. Okay, so now you're saving your packet tracer, you're saving your Word document, and you're uploading both. Okay, you're saving your packet tracer, you're saving your Word document, and you're uploading both. All right, so it is 3:35. We are going to take a break until 3:43. And then we're going to come back and we're going to talk about lab 1110-2. Okay? I think I left my water in the bathroom. 3:43. All right. So the next thing I want to do, so remember from this point on, we're not going to probably do any labs in class together anymore. Maybe one more, but it's unlikely. So you want to make sure that you're looking ahead at what labs are due. There's 2 labs due this week. There's one due from last week. That was due on Saturday. So you want to make sure that you're looking ahead and planning and getting in here during open lab time. I have been coming in early, like Mondays and Wednesdays. Usually lab opens at 1:30, but I've been coming in usually at noon. Today I was here a little bit earlier, so if there's a day that you want to come in, if I'm available, I'll be happy to come in. Also tomorrow we're opening lab at 9 a.m. Okay, so again, we're trying to, I think we've got Pam back, so we're going to try to add a few more lab hours, but you want to be able to make plans to get in and get your labs done. Okay, with that,
have it during the times that were published in the course, and then other stuff like lectures and stuff, you just do online at home.
they can do that too, but I don't.
I just assumed that there were people that didn't make their life plans around the times that were.
Well, that's why in Find a Class it says that there's work required outside of class, and then also the first day of class, and it's the syllabus that we outlined it early on. That's why it's a 4-credit class, because it has outside time required. So, all right. If you could go to week 7 labs. Okay, so we're in week 7. What I want you to look for is this 11.10.2a. Okay, so the lab for module 11, it's in 2 parts. The first part is the VLSM addressing scheme. So if you notice, module 11 covers IPv4 addressing. So this is when it really digs into VLSM. That's why we've been building up to VLSM over the last several weeks, because it's really hard to learn network addressing and all the subnet mask and VLSM in 1 or 2 class periods. So we've been building up to it. Okay. So let's go ahead and open up this. This lab has you design and implement a VLSM addressing scheme. So instead of doing a separate VLSM assignment, we're going to go ahead and work on this one. So first of all, again, I just want you to get in the habit. Let's just look at the network, right? Let's just look at the network and see what we can tell about it by looking at it, okay? So if we were to just look at the network by itself, how many networks do we need? Just looking at the topology. We'll look at this here in a minute, but let's just look at the topology. Yeah, 3 networks, right? Wherever my interfaces are on my router. So I've got a network right here. I've got a network between my 2 routers. And then I've got another LAN network off of BR2. Okay. Now this is giving us some additional information, right? So if we read this, variable length subnet mask was designed to avoid wasting IP addresses. Of course, that's because we're still using IPv4, so we have to concern ourselves with not wasting addresses. So VLSM is subnetting a subnet, right? And you can repeat it multiple times. So it's like taking a pie and cutting it up and then cutting it up again. Let's see. In this lab, we're going to use 192.168.33.128/25 to develop an addressing scheme based on the topology. Now, if you notice here, it's got some future LANs that we're going to account for because we're thinking in the future we're going to be adding some networks. Okay? So again, this is something that's very common, either if you're working for a company and you're the network administrator, maybe you're a consultant. One of the things you always want to be talking about is, oh, well, are you going to be adding anything? Are you going to be growing? Because if you can plan now for future growth, it'll make less work down the road for having to reconfigure or redo VLSM, redo all your addressing, okay? So if we look at it from that perspective, we accounted for the 3, and I have to account for how many more? 3 more, right? I have to account for 3 more. So I need a total of 6, okay? I need a total of 6. So let's go ahead and take a look here. We're going to examine the network requirements. Okay, based on the topology, how many host addresses are available with a /25? So we've got a /25. That's what the ISP is giving us to start with. /25?
Oh, wait. 128.
Right, so that's how many total are available. Okay, so how many addresses does this topology need? So just count that up and add that to your answer sheet. You don't have to call it out. So you're looking at this topology and the host requirements, and you're figuring out what it is that you need. Everybody get their answer filled out? So how many total addresses do I need for this topology? Okay, so do we have enough if we use a /25? Okay. Does everybody see how we came up with the 80? Like you've got to add 40 plus 2 plus 25 plus 5 plus 4 plus 4. So we want to make sure that we have enough for everything, right? So we need a total of 80. And how many subnets did we need? 6, right? We need a total of 6 because we're planning for the future. We're planning for the future. Okay. Now when we start doing VLSM, which network are we going to start with first? The one with the most hosts. So in this situation, which one is it? Let's see. Yeah, it's the BR1 LAN, right? BR1 LAN. So you're going to get that in there. Okay. So go ahead and do VLSM based on the requirements for this lab, okay? So fill out your table. Yes.
I thought it was a joke in the reading. I was like, things?
Internet of Things.
How does that, like,
Well, the Internet of Things would cover things like electrical outlets, electrical lights, your coffee pots, or not electrical, but internet activated. So Internet of Things is referring to like everything can be attached to the internet. Exactly. So they just call it IoT, the Internet of Things. I mean, they have full careers with people that are doing IoT work. Yeah, yeah. When you're done figuring out the network addresses and the first and last usable, you can go on to figure out the interface addressing. So remember, which address do we usually use on our router interfaces, the default gateway? Which address would I use? Yeah, first usable. Okay, and that's what it's telling us. Assign the first host address in the subnet to the interfaces. VR1 should be assigned the first host address, right? So we're using the first host because that's going to be our default gateway. done?
I think so. I struggle with DSLM, but I think I got it right.
Let's see. That looks good, and we're going to increment by 64. That looks good. Increment by 32. 232. I think that looks
This is
right.
the first time I've like gotten this far.
Yeah, I think it looks right. Yeah, so fill in the table, right? And then you can do this part. Let's see. Well, isn't this the address they gave us? That's one we started with, right? So if you need 40 addresses, which subnet mask would you use? Would you use a 25?
Yeah, that's.
You
what is
sure?
it? It's like a 26, I think it is, or a 27. Okay. So I can see that way. I wasn't sure because they gave you 25, so I thought you start with your first one to 25.
You start with the address, but it gets a new subnet mask. Always on the first one. So remember, the ISP is always going to give you a bigger address than what you need so that you can cut it up,
Okay.
right? So yeah, this guy is going to be based on
40, so I need 26.
exactly.
Okay.
Okay. How's it coming? Oh, that looks good. Uh-huh.
So even though the prefix length is different, we
Yeah.
just drop down the increment, right?
Yeah, so let's
that's
see.
correct?
128 is going to increment by 64 in the fourth octet,
So
and that will,
192?
yeah, that
Okay,
looks
cool.
right.
Got it.
Right, 128 plus 64 is 192. And then this one increments by this in the fourth octet to give you this address.
Okay, same deal.
Mm-hmm. Okay. How comes it?
Good. I tried first doing this part because I was always confusing this trying to switch it across. I don't know.
Yeah. So wait, it's easier for you to go straight across or to go down?
Just focus on this part, then.
Yes, that's what I do. I do all this, then I do this, then I do this, then I do this,
I remember
and I
mixing
do
the two,
this.
just counting downward.
Yeah. So like this one, so make sure you get your slash notation behind there. So you're going to take this address and you're going to increment it by that in the fourth octet to get this address.
Okay, so 128 plus 64, and then that would be that.
Yeah,
Oh, okay.
right? And down.
And just keep
You're kind of working backwards to get this one. Then you'll work backwards to get this one. Then you'll work backwards to get that one.
So basically, whatever answer I get for this, then I would do an increment. Of
Yeah.
that. Just keep bringing it down.
Mm-hmm.
Okay, yeah, instead of trying to go across, that confused the hell out of me.
Yeah, I agree. I get the first chunk done and then. How goes it?
It goes, there's numbers in there.
That looks right. Oh, wait, okay. So if the network is 128, what would the first usable be? There you go. That's easy. And then let's see, 32. Is that right?
Oh, I incremented that.
right? So you've got to increment 192 by 32 in the 4th octet to give you this address. There you go.
Because I wrote 25, but I actually started by a 64.
Yeah, you
incremented,
actually
so-
incremented right,
so
yeah.
the math was all right.
Uh-huh.
right? Okay.
You literally just had that first thing wrong, but you had incremented right. Now, this one is wrong, I think. So 192
Yeah.
increments by 32 in the 4th octet. So if you add 32 to 192,
To,
I think you've got bad math there.
oh, okay.
Yeah, so that might mean
Yeah,
the
I added
rest are down.
Yeah, I added 8
Yeah.
instead of
Remember, you work across, then you go down.
120 and 64 and 192.
Yes. So I think this is 224 maybe? Or, I don't know, let's see, 90.
Yeah,
So that's 4, yeah, 2, yeah. See, you do what I do. I just, and then I just change those.
Yeah, but sometimes I forget to change the cell that mask, and then I'm like, wait,
Oh, yeah.
30, where are these supposed to be? And like the broadcast address will always be odd. All hosts
Yeah. The broadcast will always be odd. The last usable will always be even. The first will always be odd, and the network could be either. If there's, yeah. Got it. Looks good. Is that, oh, I'm sorry. I think you have a typo right there.
Oh yeah. No matter how slow I move, it still happens.
I know, I get it. Let's see, and then 8, 2. Yeah, I think that looks good. I don't see anything else obvious.
Just practice.
Years of practice, yeah. But I still don't always catch everything. But I always check the first line, because if you have a mistake there, everything down, right? So that's part of the reason is I always look at that very first line. So if you make a mistake on the 7th row, I might not catch it. Okay, so once you're done with your addressing, remember the next step is we're going to assign interface addresses, because our router can't work without IP addresses, so that's the next step. So you're setting this up so that when you do the physical lab, you've already got your addressing. So normally the lab gives you all of that information, but you're doing it this time. You're preparing it.
It's good to break it up. I think my spirit would be broken if I had to be VLSOM and then do that. Just be
It helps a little.
for the first time like that.
Don't want a broken spirit. It works fine.
Does it?
Yep.
Because of the not the MDAX, what was the auto negotiation?
The main reason is because the switch is just not picky.
Okay.
Yeah, it's just not picky. So, and auto MDX takes effect too, but more than anything, it's just, it's only capable of, the weakest link is the slowest link. So, you know, that is going to be a factor, but they'll still work. When we start running into problems is when we're doing something like ether channel, which we learn about later, then you can't mix your speeds because they all have to work together, but with these guys, they don't actually have to work together. Yes. If you're done with the network addressing part, can you raise your hand? Okay. How's it coming? Let me see. Well, so you see here you need 40 addresses, right? And a 26 will take care of that. So that means you have a new subnet mask of a 26, not a 25. So change that. So let's see. And then scroll up here. So this is your biggest one, right? And then which one is your next biggest? Right, so the next one is the BR2 LAN 25 with 25 hosts. So let's go down. So that's the one. How many addresses?
So it's just gonna be 25. I was not gonna add these to it.
These are separate, so these are all different networks. BR1, BR1 to BR2, BR2, BR2 IoT, BR2 CC25. These are 6 different networks. So you're gonna have 6 different rows. So the next one is 25. Okay, and then what prefix length takes care of a 25?
That'll be 32, so 27.
Mm-hmm. Okay, so are you back on track? Okay, so you got to capture all 6 of those in there, okay? Okay, so we're going to work on this for a couple more minutes, and then we're going to call it, and you might have to finish the rest of it on your own. Mm-hmm.
It's asking for the first host address.
Uh-huh.
But so this one is BR1, the router, and BR2. They both have the BR1, BR2 link. So is it the same for both of them? And I put the network address, but I realized it's probably the first usable.
Well, let's see. Let me go up and look. Sometimes they have typos. So scroll up.
So yeah, this.
So
They
BR,
each have
oh,
their own
I,
interface, and there are their own routers.
yeah.
So that's, I mean,
Okay.
like, the default gateway
So let's see here. So BR1, G001.
would be, yeah, so that one's simple, because that's the
So
40 host line.
BR1, that's this guy, right?
Yes,
And then,
but it's
40.
asking for the,
and then G00,
is the routers to each other.
right, so that's just saying that's the name of this link, BR1 to BR2, so that's this one, G00. So, yep, G00. And then on BR2, again, it's just referencing the name of the
Okay.
link, that's all. G00 on BR2. Again, if we look at just the name of it, it's BR1 to BR2 link. That's
Okay.
why it's in there.
So it is the same.
It's the same.
Gotcha. And then
Yeah.
I would put the first host one, not the network.
Uh-huh. Right. So the IP address, because remember, if you put a network on there, it can't do anything.
Yeah.
So it's going to be the first usable, the
249,
first
129.
usable. Now, actually, we got to think about this. See, there might be a mistake because this would be the first usable, but that one's probably
that's what I
got to
was
be,
gonna say.
what does it say here? Does it assign the first host? It should be, oh yeah, see, it probably needs to make a little, I mean, at the level that we're at, it might help a student if it said, use the second one here, right? But really, it's whatever the next available one would be. So good catch. Yeah. Yeah. So, yeah, let me, just one sec, Jonah. So let me just point out something that Darren just pointed out, because I think it could be a little confusing on here. So this is a network, right? So somebody give me what this network is, BR1 to BR2. What is it, Darren?
The network address is 192.168.33.248/30.
Okay, so that's this network, BR1 to BR2, 2 hosts, right? So when you're doing the interface addressing, so everyone pay attention because this will give you a problem if you're not paying attention. The addressing says to use the first usable address, right? So what address could I put right here? What's the first usable address? 249, right? The .249. Does everybody see that? Okay. Now, these are the same network, right? So what address can I put on this interface? 250. So again, the instructions say use the first usable address, which you do, but you can't give both of them the same address. So you gotta make it the next usable, right? So 249, 250. Because you can't have a 249 and a 249. It would give you a duplicate address error, and it wouldn't work. Okay. So for this network, you give this 249, and you give this one the .250. Okay. Again, here it says use the first usable. That works. Use the first usable. That works. When you're connecting two routers, are you actually setting up default gateways? No. Remember, so listen, the term default gateway applies to what? LANs. LANs. So when I put the first usable address right here, this term is a default gateway because it's taking care of the LAN. It's the gateway to my LAN. So what's the network address for this? 26. So what address goes right here? 129. And this is called my default gateway address. Okay, that's my default. But when we're connecting two routers, That's not really a default gateway. It's just an interface with an address on it, okay? Again, it's just, you know, potato, potato, okay? Let's take a look.
I think it's probably the newer. That information proved this wrong. So.
128. Okay, so we're incrementing by 64 to get 192. We're incrementing by 32 to get 224. We're incrementing by 8. We're incrementing by 8. And this 4. We're incrementing by 8. 240. No, you're right. What did you think you have wrong? Yeah.
These two that I've been confused on.
Yeah, so the broadcast address, that's just an address that can't be used in your network because the network itself would use it to talk to everybody. Now, when we're talking about two routers, there really isn't such a thing as a broadcast because look, there's only one way in and one way out, so there's nobody to broadcast to.
For interface G00 up there, it was 192.168.33.150 or 250.
249.
Or,
2.
249 for BR1, and then BR2 was 250.
Yes.
So can that be the last usable address and the interface up there?
Yes, it is.
So it's two separate addresses?
Well, see, yeah, it's two. So scroll up and look at your network. So you have to have an address right here, and you have to have an address right there, all from the same network. See how this is one network?
Okay.
So this is a network. So since these two are connected to each other, that's just one network. So the addresses have to come from the same network. They can't be from a different network.
So you couldn't add anything else there, though?
No,
Just
you
switch it
can't.
over.
There's not a switch. There's nothing else to add. Okay, so like if you scroll down here, right? So G00, that's the link between the two, right? So that one gets the first address. And then the next one off of BR2 G00, that's going to get the 250. One gets 249 and one gets 250. There's only two addresses really even available. Okay. Yeah. Okay, so what I'd like you to do is save whatever you have done and upload it. Save whatever you've done and upload it. If you finished, that's great. You're ready to go on to the next part of the lab. If you haven't, you've got a little bit left to do, okay, before you do your connections. But I want you to save what you've done and upload it, and then finish this a little bit later. And I want to talk about we need to move on in order to talk about some private and public addressing. Okay, so save what you've done and upload it. I should see everybody uploading stuff. And I think almost everyone got most of the way through, at least halfway, and then some people got all the way through. But I think everyone's pretty much got halfway through. Did you get yours, Tony? Your networks, mostly? Okay. So upload it. You might need to finish this, before you actually do part B, because you need this addressing to do your lab.
I already uploaded it, so
Perfect.
when I go home, can I just like reopen it?
Yeah,
Oh, okay.
absolutely. You just reopen it and finish it, and then upload it when you're done. Yeah, you're mostly, you just have a little bit left.
Yeah, I just have the part left.
Yeah, so again, remember, normally your lab gives you all the addressing, but you're figuring it out first, and then you'll be using that on your lab. Okay? You will not have to do it for every lab, right? We'll do it again. There's one more time that we'll do it. And in the real world, you do it every day. You'll do it a lot, right? Now there are VLSM calculators. You can use a VLSM calculator. My advice is just get good at addressing, right? So that you don't have to rely on the calculator. It really helps with troubleshooting. And then, when you're out there, if you got to figure out a big network, you'll use a VLSM calculator. Or you'll double check your work using a VLSM calculator. Like I almost always do my own VLSM because I just want to keep my brain in the game. You know, I just want to keep my brain in the game, and the more and the better I am at addressing, the better I am at solving troubleshooting problems. Because what are the two most common problems? Cabling and addressing, right? So you're going to be dealing with addressing trouble a lot. Just happens. And so the better you are at addressing in general, the quicker you'll be at troubleshooting. That's really where that comes from, okay? So module 11, again, what did you notice about module 11, the whole first part? The whole first half of module 11. Blake? Yeah, it's like a review of almost everything we've been doing, right? Like subnet masks, finding the network address. Okay, now, and then it moves into stuff that's a little bit newer. Now, something I want to talk about that we haven't done, but I want us to think about it. So if I give you a /26, what are the total number of host addresses? The total number, or just the total number of addresses. Let me not say host. The total number of addresses. 64, right? 64. And then what are the number of usable addresses? 62. Okay. If you have a /26, how many networks can you get? How many networks can I make with a /26? How many? And how'd you come up with 6? Okay, so I'm going to reverse engineer a little bit. So if we're talking about hosts, right, it's 26. How many host bits are there with a /26?
4.
How many host bits? There's 6 host bits, right? And the way we came up with this 64, what was the math? What's the math to get to 64? Two to the power of 6. Is this something we've all forgotten already? Right? So if I have a /26, I have 6 host bits. The math, right? We use the easy chart. But the math behind the easy chart is 2 to the power of the 6th, which equals 64 minus 2 equals 62. Why do I feel like that? Okay, what about, let's do this one, a /18. How many host bits for a /18? Well, give me the bits, the number of bits first. Okay, so 14, right? I have 14 host bits. This is all from the first week, first or second week. What's the math? 2 to the 14th. Now give it to me, Darren.
Well, you want the usable addresses? Or
Total.
16,384.
Minus 2, right? 16,382. Okay, so we took the number of host bits, right? We took 2 and raised it to the power of the number of host bits, right? That's what this whole chart is. 1, 2, 4, 8, 16, 32, 64, right? That's just the easy way to remember that, so you're not having to do that math in your head. Are we good with this? Does everybody remember that? Okay, so now I want you to think about my question in terms of what we just talked about. A /26, we figured out how to do the host bits, right? And how to figure out the number of hosts. Use the same math. How many networks can I get? Use the same math. How many networks can I get? It's a little different.
Would you just raise the 2 to the power of your slash notation, basically?
Close, 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 close.
Or the difference?
So, Darren said, so we're dealing in binary, right? So 2, we can only either have a 0 or a 1. So 2, that's why it's called binary, because we only have 2 values, 0 and 1. So it's going to be 2 raised to the power of something, just like the math for hosts. There's a difference, though. So with the host bits, we actually did the total number of host bits. When we need to figure out the networks, we're just looking at the octet. Okay, we're just looking at the octet. So a 26 is in what octet? 4th octet. How many network bits are turned on? 2. So what would the math be? 2 to the power of 2, which equals 4. Okay, so if I have a /26, how many hosts can I have, total usable hosts? And how many networks would I be able to get? 4. Okay? Now, a /18, what octet is that in? The 2nd octet or the 3rd octet? 3rd octet. How many network bits are turned on in the 3rd octet? So how many networks would I be able to get with a /18? 4. Okay, so if we do a 26, okay, 24, 25, 26. So when we figure out the hosts, we just look at hosts, right? Now we want to figure out the network, the number of networks. So I'm just looking at the networks bits. So I have 2 network bits. So 2 to the power of 2 equals 4 networks. That's it. That's it. 18. /17, 18. Okay, we're just looking at the octet. How many network bits? And 2 to the power of 2 equals, okay, so how about a /27? Everyone, if I have a /27, how many host bits are there? How many host bits? There's 5 host bits, and how many addresses, Jonah? 32. How many usable? 30. Okay, so there we figured out the hosts. Now with a 27, how many networks could I have? There's 3 network bits equals 8 networks. 8 networks. Okay, so let's prove it, right? So let's just prove it for a second. It's the same math. The only difference is I don't subtract 2 because I'm not worried about a network address and a broadcast address, okay? So I don't subtract 2. Okay, so we're going to prove something to ourselves, right? So let's say I have a 192. Okay, so there we have a 192.168.00.26. Okay, so how many host bits? Right, so I have 6 host bits. Okay, how many network bits? 2 network bits. Okay, so how many usable addresses? Usable. Usable addresses are 62. How many networks? 4. Okay, so we're going to prove it. So if I have a 26, it increments by what? Everybody, what does a 26 increment by? In what octet? Okay, so my next network address would be what? Okay, so here's 1 network address, here's 2 network addresses. Okay, so what would the next network address be? So my 3rd network address would be what? Okay, and what would my 4th network address be? Somebody. So 64 plus 128 is? Okay. So now if I added 64 to 192, what do I get? 256. And is there any such thing as a 256? There isn't. Okay, so I got 4 networks from a /26, and we just proved it. Now, can I go into the other octet? I can, but we're just going to keep it simple for where we're at right now, okay? So a 26, I had 2 network bits turned on. 2 to the power of 2 equals 4, and I just proved it by incrementing by 64, that I get 4 equally divided into that. Okay? So how about a /24? How many networks can I get from a /24? How many network bits are turned on in the 3rd octet? What's 2 to the power of 8? 256. (192.168.0.0/24). What do I increment by? In what octet? What would my next address be? What would the next network address be? What would the next 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 address be? See where I'm going with this? .7, 8, 9, 10, 11, 12, 13, 14, all the way down to 192.168.255.0/24. 0 to the 255 is 256 networks. Right, right. Okay, so when you get a question that says a /28, how many usable hosts do you have? How many usable hosts do you have with a /28? 14. How many networks? You have 4 network bits. How many networks? 16. 2 to the power of 4 equals 16. You have a /29. So if we have a /29, how many usable hosts do I have? Okay, I have 6 usable hosts. How many network bits do I have? 5. So 2 to the power of 5 equals 32. So how many networks could I get with a /29? Okay, how about with a /21?
So it's the same thing.
Same thing, a /21. Okay, if you have a /21, what octet are we in? 3rd octet. How many network bits are there? 5 network bits. What's the math? 2 to the 5th, which equals 32 networks. Okay? So we use the same math. 2 to the whatever the power is. Okay? So if I tell you I need 6 networks with 12 hosts. Okay, so I need 6 networks with 12 hosts. What would work for that? Each. Yep. So I need 6 networks, each with 12 hosts. If I had a /25, okay, so let's do the math. How many network bits in the 4th octet? So 2 to the power of 1 equals 2, so that doesn't give me enough. Okay. Right. Exactly. So if I have a /28, how many hosts would that give me? 14 hosts. So that meets this, right? And how many networks would I get? How many? So I have 4 network bits. 16 possible networks. Would a 27 work? I'd have more addresses, right? So if I had a /27, I'd be closer to the number of networks, but I'd have a lot of wasted addresses. So there is a decision that you just have to make as a network administrator. And usually, is it better to waste networks or better to waste addresses? Probably networks. You want to avoid wasting addresses when you can. But if we're going to grow, right, so you think about all of those different things. Okay, think about all those different things. All right, so someone explain to me what a default gateway is. Okay, and can you be more specific with what kind of a network? LANs. Right? And give me some more information. Like, what is it? You said it's an...
So it's where the packets from one destination will point to leave that network.
Okay.
Into a remote network.
And what actually is it? It's just an interface on the router that has been assigned
First usable address.
an IP address. And it actually can be any usable IP address. Why do we use the first usable? It's just the easiest to keep track of, right? And it's very common to do in industry. Now, sometimes I see companies use the last usable address as well, but they're never going to typically use a random address, because that's really hard to keep track of. Okay, that's really hard to keep track of. So right here, I would assign my default gateway, right? And what is the broadcast address used for?
Sending out packets to all of the hosts.
Yeah, everyone on that domain, right? So that's called a broadcast domain. Yep, that would be another reason to use it, depending upon whether we're doing ARP. We might be using a 255, 255, 255. If we're using a Mac, FFFFF. Exactly right. All right. So RFC 1918, because again, America mostly is trying to figure out ways to never use IPv6, they had to come up with private and public addressing. So what is the difference between private and public addressing? What explains it?
Public address is one that can be sent across the internet to a different network.
Yes.
The private one is, you can have whatever you want, as many as you want. You can't leave your own network. You can't interact with outside networks.
Exactly right. So like in here, we all have a private address. And so we cannot, like we literally couldn't get out of this LAN except that we do have a public address associated with our default gateway. So if you needed to send an email to, again, Pennsylvania or Gilbert or Mesa, it can get out because we have a public address that it can associate with. So have you all seen a relay race? Right? You pass the baton. Okay, so that's kind of what happens with private and public addressing. Okay, so we use what protocol in order to pass that baton? Network address translation, NAT. So we have a private address in here, which happens to be a 10 network. Okay, so we're running the race. I get to my default gateway. I have the baton, and I need to talk to somebody in Pennsylvania. So I hand the baton over to the default gateway, more or less. I mean, this is simplified. And from there, network address translations will say, oh, this is a message that needs to get to Pennsylvania. So it now attaches that to the public address. Now, the public address can get out and go over the internet. It can ride over the internet. Now, that private address, so remember I told you routers keep track of a lot of tables, right? Keeps track of ARP tables, routing tables. Well, now it also keeps track of NAT tables. So it's going to store the private address 10.10.10.10. It's going to sit there, and it's going to do the baton pass. The public address is going to go out and do its business, right? The private address just kind of sits there until the message comes back from the public address to deliver it back to me. So maybe it's like a response. You know, I'm sending a message, then it will respond back. So our routers also keep track of NAT tables, where it's going to match up the private address to whatever the public address is. Okay? So what are the ranges of private addresses? That we have 3 ranges of private addresses. Yes, yes, 10.0. Yes. Yes. Everyone got that? You should have it in your notes, if not. So there's 3 ranges of private addresses. So in here we have a 10. Now, one of the things that determines whether you get a 10, a 172, or a 192 is the size. We're a government agency, so we're big. So they give us a 10 network because it's a / what? /8. So there's a gazillion addresses. Not really a gazillion. Okay. What is our Cisco network? A 172.16. Right? So it's a private network. It doesn't ever get out onto the internet. Now, chances are at your house, do any of you know what you have at your house? Do you have a 172?
I thought you were asking about public.
Nope.
No, like 192.
The 192. Most of us at our houses have a 192. I've seen every now and then people have a 10. I have a 192, but I would say most people get a 192. Okay? So private addresses, they never leave the LAN. They never leave the LAN.
So even though it's private, it's still, you're assigned that from your ISP?
You are. Yeah, and if you wanted, you could get a different range. You know, I mean, chances are they would give you, if you were to call up and say, I don't want this 192, I want a 10. They probably have 10s that they, I mean, they don't care. Yeah, but they would even give that. So like on your router, that's assigned by them. And I've seen them give a 23, a 24. I've seen them, lately they only give 24s. But like probably 5 to 10 years ago, they didn't even give 24s, they gave smaller. But now that people have so many devices, they're almost always giving a 24 because the chances are I'm not going to have more than 254 devices. And an ISP, if you tell them you want like a 20, they'd probably charge you because they can. Doesn't cost them more, but you know. Yeah, right. Don't ask any questions. Just trust me, I have 1,000 devices. So when we talk about private and public addresses, then we also need to talk about class of addresses. So there's a class A, B, C, and a D, okay? So what makes the difference between an A, B, C, and D? Yeah, it's the amount of hosts. Exactly right, it's the amount of hosts. Now what is important to understand is that's called classful addressing versus classless, okay? So a /8, a /16, or a /24, A, B, and C. What if I give you a /23? What kind of address is that? It's classless. So whenever you don't have something on the octet boundary, do you remember that word? Octet boundary, a /8, a /16, a /24. Anything not on the octet boundary is going to be classless. A /22, classful or classless? Okay, so tricky question, a /16. What's the answer? The answer is it depends. And I'm going to explain, okay? So let's see, we've talked about network address translations. All right, so let's do this matching. Tim, loopback, which one is it? It's there. Is it? Any 127.0.0 whatever is a loopback. So 127.0.0.25, Aiden, which one is the APIPA?
It's the 169.
It's the 169. And what does that mean, Darren?
I don't remember. It's just, it's like when there's a misconfiguration and it like defaults to that. Like if there's you're connected to your network, but your network's not connected outside of it.
Okay, so write this down. If you have a 169 address, that's an APIPA address, and that means it's not finding a DHCP server. Okay, so these devices, they want to talk no matter what. So they're going to assign themselves an IP address because they're so desperate to gossip. So when you see a 169 address, that means that A, an address hasn't been statically assigned, and the device cannot find a DHCP server. Okay? Jonah, which one of these is a multicast address? Multicast.
172.
Which one?
172.
Not the 172. You were closer the first time.
224.
Yes, the 224. So multicast addresses start with a 224 through a 239. So if you see a 230, a 233, a 234, a 239, any of those are going to be a multicast address. And what's a multicast address? one or more? More than one. It has to be more than one. Two or more, right? It means I'm sending like a group, right? Just not one, exactly. Well, not one and not all. Yeah, not one and not all. Tony, which one of these is a private address? Nope. Oh, wait. Yes. Yes, yes, yes. And which else? So remember, there's 3 ranges of privates. The 172. The 10. Yeah, so the private is the 172 and the 10. And what else is private? A 192, right? A 192.168. Public. Oscar. 216, right? Because it's something other than 192.168. It's something other than 172.16. And it's something other than the 10. And then we all know the broadcast, right? 255. Okay. Let's see. Right. So it the NIC card will self-generate a 169.
What if you statically assign a 169?
I don't know. It would be able to communicate as long as there's another 169 device for it to communicate with. So like the thought is, let's say you come in, you turn on your computer, and it gets a 169. It can't find the DHCP server. Chances are there could be a problem with the whole network. So they'll all generate a 169. That way they can talk to each other within their LAN. They can start, I mean, they can talk to each other as long as they can learn the multicast their MAC address. But remember, they might not know the other MAC address, so it has to rely on IP address using ARP. So for ARP to work, it has to have an IP address, right? Let's see, dynamically, DHCP. Okay. So I want to cover one last thing before we go. So this is really important. When you have an A, B, C, and a D class, it isn't just the slash notation that matters. It's the bit configuration. So for a class A to be a class A, not only does it have to be a /8, the first bit has to be turned off. So that means the value has to be less than 128. Okay, so that's what makes a class A. Not only is it a /8, but the first bit is turned off. Okay? So now let's look at a B. For a B, it has to be a /16, and the first bit needs to be on, and the second bit needs to be off. Okay, so there's more than one factor that makes an address an A, a B, a C, or a D. Both things have to match up. So if I said 172.5.5.5/8, is that an A, a B, or classless? Classless. Classless, because the first bit is turned on, and it's a /8. That makes it classless. So you have to meet both criteria, okay? So a C, you have to have a /24, and you have to have a 110, okay? A 110. In order for it to be a class C. So if I gave you the address of 216/24, Would that be a Class C? Yes. 216. So bid out 216 for me. There we go, and I said it was a 24. Bam, it's a Class C. Okay, we'll do more of these on Wednesday, okay? But the thing I want you to walk away from is you've got to make both criteria match up. It can't just be one. And then for a Class D, oh, that's wrong. This is here, this. It has to be a 1, 1, 1, okay, for Class D, because it's got to be a 224 or a 230 or a 239, okay, so it's got to be a 1, 1, 1, 0 for it to be a Class D. Okay, so that's what I want you to walk away from, is you have to match both criteria for it to be a classful address. All right, so we're going to pick up from here on Wednesday. Right, right. First bid on, second bid off. Okay. First bid on, second. What about for a Class A? First bid and the slash notation? 8. So if you have those two, you have a classful address. So if I have a 192/8, what is it? Classless. Classless. Okay? All right, so we'll pick up from here on Wednesday. A public address is going to be in the range, it can't be a 10, a 172, or a 192, or a 224. Everything in between are public. So like an 11 would be a public, a 12 would be a public, a 216 would be a public, a 200, a 93, anything in between. But it can't be a 172/16 through a 172/31. And it can't be a 10 or a 192/168. If anyone wants to stay and finish their addressing, they can stay and finish their addressing. Bye, Darren. Yeah.
Switch one, BR1.
Yes.
Is that referring to? So is it going to be BR1 and slash host address?
It would be. So it would be this network.
Okay.
So whatever the network is for this one, so you used the first address for this address, and you're going to use the last address on the switch, but these boxes represent the networks.
Okay.
Okay.
So if it was switch 2, that's going to be BR2 land?
Exactly.
Okay, and the last host?
Mm-hmm.
Okay, got it.
Yeah.
Thank you.
Do you need me, John? Oh, for Blake. For who? Oh, for Blake. Okay, I'm like looking. Goodbye. Goodbye. Thank you, Tim, for doing your homework. Hey, now.
Turn it in early unintentionally, I guess.